Hi, hello everybody. So this is the video dealing with section 2.6, rational functions and their graphs. And this is the second part where we're going to go over the concept of horizontal asymptotes. So a rational function, which is a ratio of two polynomial functions, may have what we call a horizontal asymptote. So it's similar to the concept of a vertical asymptote. You can see here in the graph. This is going to be a horizontal line that the function, just as the vertical asymptote, the function never reaches and never crosses, but gets closer and closer as the value of x either approaches positive or negative infinity. So this is pretty much like end behavior of the polynomial as we go either to positive infinity or negative infinity. So same representation as a dashed line, but now it's a dashed line parallel to the x-axis. So there could be three possible ways that this can happen, right? The function may be approaching from left to the right, uh, or obviously right to the left, either from the bottom up, so this is bottom up, or this is from the top down. So this is the two classical ways that it can happen. And this, most of the cases, this is going to be that way. Or it can be that the function is going to do something and bounce back either from the top down or from bottom up that way. So either going to the right or going to the left, but it's the exact same way. Okay, so this is an end behavior of the function, right? And the function is going to approach, it doesn't matter right or left. It just matters if it's going from the bottom up or from up down. Okay, so these are the two most familiar cases. And when you find the horizontal asymptote, in the vertical asymptote, the equation was x equals a, which was the root of the denominator. In this case, notice that the horizontal asymptote is going to be y equals a value. All right. So it's not x equals, it's y equals. So it's important that you write the horizontal asymptote correctly. This is going to be the format of the horizontal asymptote. It's an equation and it's always y equals. The vertical asymptote has equation x equals always. X equals a number for the vertical asymptote, y equals a number for the horizontal asymptote. Now, how do we find the horizontal asymptote once we have a rational function? Well, this is very easy because, like I said, this is just the end behavior of the polynomial. So we are going to write the rational function in expanded polynomial format with each term completely spelled out, right? From the leading term to the last term. Same thing with the denominator, leading term and the last term. Now, once we have done that, because this is end behavior analysis, all we have to do is look at the leading terms of both numerator and denominator. So I'm going to write it here. This is the only thing we're interested in. This is the leading term of the numerator. This is the leading term of the denominator. Whatever it is, we don't care about anything else, just the leading term of both. And then we're going to take a look at these three possibilities. This is the n exponent of the numerator. This is the m exponent of the denominator. It's the highest exponent of the denominator, highest exponent of the numerator. If the exponent m is smaller than m, then the rational function has a horizontal asymptote at 0, y equals 0. If the two values are the same, the two exponents are the same, then the rational function is going to have a vertical asymptote at the ratio of the two coefficients. Okay, so for example, if I had 4x7, 2x7, then the horizontal asymptote would be, since these two are the same, 4 over 2, y equals 2. If, on the other hand, the n exponent is bigger, right? So 2x7, 3x5, the n is bigger than the m, then the function has no vertical asymptote. So these are the three possible scenarios. Okay, we just analyze the leading term of the numerator with the leading term of the denominator, and then we apply these three possible scenarios. If the exponent of the numerator is smaller, y equals 0 horizontal asymptote. If the exponent of the numerator is equal, then the asymptote is y equals the ratio of the two coefficients. And if the numerator exponent is greater, then the function has no vertical asymptote. All right, so let's take a look at three examples. They're extremely easy, depicting these three scenarios. I'm going to leave it here so that you can see. Right, so example 3, again, taken from the book. You can look at the results later. Case A, here's the function. And notice that in both scenarios, both polynomials are fully expanded. So I'm only required to check the leading term of the numerator, leading term of the denominator. Now, what is n in this case? N is the exponent of the leading term of the numerator, which is 1. What is m? M is the exponent of the leading term of the denominator, which is 2. This one right here. Okay. Now, since n is smaller than m, then I have case 1, which is asymptote y equals 0. So the function is going to level off as x goes to either positive or negative infinity at y equals 0. Okay, we'll find out if it is positive or negative infinity in the other video, but for now, this is a horizontal asymptote. Okay, let's take a look at the second case. Again, both cases, the polynomial is already in fully expanded form. If it isn't, for example, if you're given something like this, okay, on the numerator, you would have to expand this and then multiply by that in order for us to find the exact term. There's a way to do it without expansion, but maybe it's easier for students to fully expand and multiply out the terms. But it's likely that on the exam, you're going to be given in, expanded format. Okay. So we'll take a look at the leading term of the numerator, leading term of the denominator. So in this case, n is 2, right? The leading exponent of the numerator. And m is also 2 because that's the leading exponent of the denominator. So in this case, both are equal. So the horizontal asymptote is the ratio of the two coefficients. Okay, so the coefficient of the numerator is 4. The coefficient of the denominator is 2. So 4 over 2, obviously y equals 2. Now notice that these two numbers, they don't have, you could have a problem that was 4x squared and then 7x squared. And what would be the horizontal asymptote? Well, it would be 4 over 7. And that's perfectly okay. It's just not a whole number. It doesn't have to be a whole number. This is where the function is approaching, 4 over 7. Okay, so we should not be afraid at this level of fractions. Usually these problems in the textbook, they give you easy numbers, but nothing special about a fraction. Let's see the third case. Again, it's already in fully expanded form. So this is the leading term of the numerator. This is the leading term of the denominator. So my n is the exponent, highest exponent of the leading term. The exponent of the leading term, which is 3. And m is the exponent of the leading term in the denominator, which is 2. In this case, n is greater than m. So this is my third case. We would say no horizontal asymptote. Okay. So this is how you find, horizontal asymptotes on rational functions. Okay. Fully writing the polynomial in this format and only analyzing the leading term of the numerator and denominator according to these three rules that you saw right here, these three rules.